And now we discuss about straight lines. Already you learnt about straight lines, line segments, line in our previous classes. Suppose we consider a straight line as are saying in the figure, the angle made by the straight line with positive direction of x-axis in the anti-clockwise direction. And this is called inclination. And in this coordinate system, x-axis is a straight line, y-axis is a straight line. And x-axis is a straight line which is passing through the origin 0, 0. And this y-axis is also a straight line which is passing through 0, 0. And next we consider slope or gradient of a line. You consider this line. This point is 1, 0. This is 3, 0. This is 3, 3. What you can observe when you move along this straight line, when you come from this position to this position, the change in x coordinate is 2, the change in y coordinate is 3. That means the gradient in y coordinate is 3, 1, the change in x coordinate is 2. This is nothing but the slope of this straight line. Slope is nothing but how the value of y changes with respect to x. This indicates the slope of a straight line. If the slope is more, we can say the variation in y is very high with small changes in x. If the slope is less, the variation in y is very less with the large changes with x. In this case, the slope is nothing but the difference in y coordinates by the difference in x coordinates. Suppose if I draw a straight line parallel to x-axis. Now what is the slope of this line? The slope of this line is 0. Similarly, if you draw a straight line parallel to y-axis, what is the slope of this line? The slope of this line is infinity. That means without change in x-axis, the y changes to infinity. In this case, with the change in x-axis, there is no change in y-axis. The slope of a straight line which is parallel to x-axis is 0. The slope of the straight line which is parallel to y-axis is infinity. The idea of slope is how the vertical axis is varying with respect to horizontal axis. In physics, we study about inclined planes. Suppose you observe these planes, which is having more slope. Yes, this is having more slope compared to this. That means, in this case, the vertical value changes more with a small variation in horizontal distance. Hence, we can consider this slope is more. For this, the slope is less. Mathematically, if theta is the inclination of the line, then the slope is denoted by m and is given by m equal to tan theta. You know why it is tan theta? Yes, tan theta is nothing but opposite side by adjacent side. That is, if I consider this triangle, the opposite side gives the variation in y-axis and the adjacent side gives the variation in x-axis. Now in this figure, the inclination of line L is 45 degrees. The slope of the line is tan 45. This is equal to 1. Suppose if this line, this is making an angle 45 degrees with x-axis in clockwise direction. That means this angle is 135 degrees. In this case, the slope is tan 135. This is minus 1. This is a line with positive slope. This is a line with negative slope. The meaning of positive slope is the value of y increases with respect to x. The meaning of negative slope is the value of y decreases with respect to x. And already we told the slope of x-axis is 0. The slope of any line parallel to x-axis is also 0. And the slope of a vertical line is not defined. That is slope of y-axis. This is undefined or infinity. Slope of any line parallel to y-axis is also undefined. We take a theorem related to slope of straight lines. Two non-vertical lines are parallel if and only if their slopes are equal. We can prove this like this. Consider L1 and L2 be two non-vertical lines with slopes m1 and m2 respectively. Let theta 1 and theta 2 are the inclination of these lines. Slope of the first line is m1 is tan theta 1 and slope of the second one is m2 is tan theta 2. Since L1 and L2 are parallel, theta 1 equal to theta 2. Taking tan on both sides, tan theta 1 equal to tan theta 2. Therefore, m1 is equal to m2. That means the slopes are equal. Conversely, if m1 equal to m2, tan theta 1 equal to tan theta 2, theta 1 equal to theta 2 and L1 parallel to L2. Theta 1 and theta 2 form a pair of corresponding angles. If m1 equal to m2, that is slopes are equal, the lines are parallel. We take another theorem. Two non-vertical lines are perpendicular to each other if and only if the product of their slopes is -1. To prove this, consider two non-vertical lines with slopes m1 and m2 having inclinations theta 1 and theta 2 as are seen in the figure. The slope of the first line is m1 is tan theta 1 and m2 the slope of the second line, that is tan theta 2. L1 and L2 are perpendicular to each other. This angle is 90 degrees. This is 90, this is theta 1. We can write theta 2 equal to 90 plus theta 1. Since this is a triangle and this is the exterior angle of the triangle. The exterior angle of a triangle is equal to sum of two opposite interior angles. Now tan theta 2 is tan of 90 plus theta 1, or tan theta 2 is tan 90 plus theta is nothing but minus cot theta 1, or tan theta 2 equal to minus 1 by tan theta 1. Tan theta 1 into tan theta 2, this is equal to minus 1. Tan theta 1, this is the slope of the first line. Tan theta 2, this is the slope of the second line. That is m1 into m2, this is equal to minus 1. Therefore, if two non-vertical lines are perpendicular to each other, then the product of their slopes is -1. And conversely, if m1 into m2 is equal to -1, then tan theta 1 into tan theta 2, this is equal to -1. Tan theta 2 equal to -1 by tan theta 1, or tan theta 2 equal to minus cot theta 1, or this is equal to tan of 90 plus theta 1. Since theta 2 equal to 90 plus theta 1, we can consider this angle is 90 degrees. Therefore, L1 perpendicular to L2. Therefore, two non-vertical lines are perpendicular to each other if and only if product of their slopes is -1. If a line is passing through 2 points x1, y1, x2, y2, then the slope, this is a straight line, this is passing through 2 points a x1, y1 and b x2, y2. And AB is a straight line passing through the points A and B. And let theta, this is the inclination of the line. Now draw the perpendiculars AL, BM on x-axis from A and B respectively. Now draw AN perpendicular to BM. Now this angle is theta. In this figure, BN, this is nothing but BM minus MN. This is BM minus AL, Y2 minus Y1. And AN, this is LM, this is equal to OM minus OL, this is equal to x2 minus x1. Now the slope of the line is m equal to tan theta, this is equal to opposite side by adjacent side, that is y2 minus y1 by x2 minus x1. Therefore, the slope of the line passing to the points x1, y1 and x2, y2 is y2 minus y1 by x2 minus x1. To take this example, find the slope of the line joining the points 3, 8 and -9, 6. A line is passing through these 2 points. We have to find the slope of the line. We consider this is x1, y1 and this is x2, y2. Now the slope of the line AB is nothing but y2 minus y1 by x2 minus x1. This is equal to 6 minus 8 by -9 minus 3, or this is 1 by 6. Find the value of P. If the slope of line joining of the points 5 minus P and 2 minus 3 is -1 by 3. Let the given points be A 5 minus P and B 2 minus 3. And it is given that slope is -1 by 3. Slope is nothing but y2 minus y1 by x2 minus x1, that is -3 minus of minus P divided by 2 minus 5. This is equal to -1 by 3. On simplification we get P minus 3 by -3 is -1 by 3, or p minus 3 is equal to 1 or p equal to 4. We take another example. Find the value of k if the points minus 2 minus 4, k minus 2 and 3 4 are collinear. These 3 points are collinear. What is the meaning of collinear? Yes, their slopes are equal. Suppose we consider the points are a minus 2 minus 4, b k minus 2, c 3 4. They are collinear means slope of AB is equal to slope of BC. Now slope of AB is minus 2 plus 4 by k plus 2. This is 2 by k plus 2 using formula y2 minus y1 by x2 minus x1. Similarly, slope of BC is 4 plus 2 by 3 minus k. This is equal to 6 by 3 minus k. Since they are collinear, the slopes are equal. 2 by k plus 2, this is equal to 6 by 3 minus k, or 2 into 3 minus k equal to 6 into k plus 2. On simplification, we get the value of k is minus 3 by 4. Intercepts of a straight line. Consider L is a straight line. It meets A and B points along x-axis and y-axis as we are seeing in the figure. This OA, this is called x-intercept, and OB is called y-intercept. This is nothing but the value of x where it cuts the x-axis. This is the value of y where it cuts y-axis. And the values of OA and OB are taken as positive or negative based on whether the line meets positive or negative axis. Suppose you consider this line. This line meets x-axis at a minus 5 0, y-axis at 0 minus 3. In this case, the x-intercept is minus 5 and y-intercept is minus 3. If the line is like this, yes, x-intercept is 4, y-intercept is 3. And equation of a line in general form. An equation which is in the form ax plus by plus c is equal to 0, where magnitude of a plus b is not equal to 0 and a and b are not simultaneously equal to 0, which is satisfied by every point on a line is called equation of a line. In general, the equation of a straight line that gives y and x value variation along the line. If you take any point on the straight line and the equation which defines the straight line should satisfy that point. Equation of x-axis. If we consider x-axis, the y-coordinate of every point along x-axis is 0. Therefore, the equation for x-axis is y equal to 0. That means if you take any point on x-axis, then we have to take y is 0. Therefore, the equation of x-axis is y equal to 0. Then what will be the equation of y-axis? As it is x is equal to 0. Why? Because x-coordinate of every point along y-axis is 0. Therefore, the equation for y-axis is x is equal to 0. Now what will be the equation of a line which is parallel to x-axis? Suppose you consider this is a line. This is at a distance k units. Now what is the value of y? Y equal to k. Therefore, the equation of this line which is parallel to x-axis, that is y equal to k. Similarly, you consider this line. This line is parallel to y-axis. This is at a distance k units. Here x is equal to k. Therefore, the equation of a line parallel to y-axis is x is equal to k. Now we consider inclined line. If we consider a straight line which is neither parallel to x-axis or parallel to y-axis, this is an inclined line or an oblique line. For this, what will be the equation? This line is having some slope. The equation of a line with slope m passing through the origin, this is given by y equal to mx. Already we know that slope is y by x. Therefore, y equal to mx. This is the equation of the line with slope m passing through the origin, which is called gradient form or slope form. And the equation of a straight line passing through the point x1 y1 and with slope m, This is given by y minus y1. This is equal to m into x minus x1. And slope-intercept form. The equation of a straight line with a slope m and having y-intercept c is given by y equal to mx plus c. The c is y-intercept, m is the slope, and area of the triangle formed by this line is half into base into height. This is 1 by 2 into c square by m square units. And 2-point form. The equation of a straight line passing through the points x1, y1 and x2, y2 is given by y minus y1. This is equal to m into x minus x1, but m is nothing but y2 minus y1 by x2 minus x1. Therefore, y minus y1 by y2 minus y1. This is equal to x minus x1 by x2 minus x1. And the equation of a straight line with x-intercept a and y-intercept b, this is given by x by a plus y by b is equal to 1. Area of the triangle formed by the line x by a plus y by b equal to 1 with coordinate axis is 1 by 2 ab square units. Why? Because this is the triangle with height b, base a, half into base into height is the area of the triangle.